Hello everyone. So today I'll be discussing question number 22 of set 1 GATE Civil Engineering 2021. A truss EFGH is shown in the figure in which all the members have the same axial rigidity R. In the figure, P is the magnitude of the external horizontal forces acting at joints F and G. If R is 500 into 10 to the power 3 kilonewton, P is 150 kilonewton, L is 3 meter, the magnitude of horizontal displacement at joint G in mm round off to 1 decimal place is. So this is a 1 mark question of fill in the blanks type, hence there is no negative marking. For these type of questions, you can refer to lecture series on Structural Analysis 1 by Professor Amit Shaw, Department of Civil Engineering, IIT Kharagpur. Now let us move towards the solution of this problem. So let us first mark the things which are given to us. In this case, we are given R, value of P and length of all the members. We need to find the horizontal displacement at point G. We'll call it delta GH. So we will use the unit load method to find the deflection of a node in a truss. So therefore delta GH is equal to P summation of PKL by AE, where P is the forces in all the members due to real loads and K is the forces in all the members due to virtual horizontal load applied at G node. So basically what we will do, we will find out the internal force in the truss members due to the load applied P and due to the virtual unit load applied at node G. Let's first find out the member forces due to the real load, that is 150 kilonewton applied at node F and G. Firstly, we'll find out the reactions at point E and H. So let us call it as RH and RE. So we can put it like summation of moment about point E equal to 0. Then what it will be? RH multiplied by 3 minus 150 multiplied by 3 plus moment due to this force now 150 multiplied by 3, so equal to 0. So what is the value of RH? The value of RH is 0. Similarly, the value of RE will be 0. So now we know RE and RH. So RH is 0, hence this will be 0. No force in this member. HE is 0, so this force will also be 0. You can find out HE also similarly. Now this is 150 kilonewton, so this member will directly take 150 kilonewton as there is no inclined member here, right? Since the entire load 150 kilonewton is taken by member FG, hence this will also be a zero force member. Now since RH is 0 and this is a zero force member, and this also GH is also a zero force member, hence this will also be a zero force member. So now we know all the forces due to the real load P. Now before finding out the member forces due to this virtual load applied at node G, let us take a step back and see the formula which we are using. So we are finding out the horizontal displacement of node G. The formula for it is delta GH is summation of PKL by AE. Here AE is the axial rigidity of the members, and here it is given as R, which is same for all the members. So how will this formula goes? This will be P1 L1 K1 by R1. Let's say this is member 1, this is member 2, member 3, member 4 and member 5. Therefore it will be plus P2 K2 L2 by R2 plus and so on up to P5 K5 L5 by R5. Here we can see that other than member 1, that is member FG, forces in all the members is 0. Therefore, automatically this P2, this term will be 0, this term will also be 0, since P2 and P3 and P4, P5 are 0. So only thing we need to find out is K1 now. With this small observation, we have saved our time to find the forces in all the members due to this virtual load. So now we know that since this is 1, virtual load 1, so the force in this member will be 1. And other than that, we don't require to solve the entire truss now. Everything is done now. We just have to put all the values in the formula and find out the solution. Now the value of delta GH will be simply P1 K1 L1 by R1. All the values are given to us. So delta GH will be equal to 0.9 mm.